them from lots of angles so that you have a good idea of solving problems. Then I give you homeworks, and the homework problems are pretty decent and good. So if you can do the homeworks well and you can do the class examples, then you already understand it pretty well. But then before the midterm, for example, I am doing an extra session of problems so that you are more well prepared. So today's tutorial basically is based on your quiz 1 and quiz 2. So it serves two purposes. One is that it is a tutorial, right? You get a lot of extra practice of solving different types of problems, including MCQs and true false and small theory questions and numerical problems and so on. And the second is that you have the full solution now of quiz 1 and quiz 2. So whatever errors you did or not did, right, now you can exactly pinpoint where you committed any mistake or not in solving the two quizzes. So what I'm calling question 1A here, we will start with the multiple choice question of quiz 1. Of course, in reality, there are many more questions. Here as a sample, I will take 5 multiple choice and 5 true false, so that you have some taste. But actually in the chapter and in the book, there would be more than this. Materials that produce electric field when exposed to mechanical force or exhibit mechanical stress when subjected to electricity are called what? You should know the answer. These are very specific materials, but the possible answers are piezoelectric materials, shape memory alloys, nanomaterials, and electronic materials. So if you remember piezoelectric materials, like the Z, remember the Z in Italian is like a tzz, half T, half Z. That is why it is not pizza that you eat, it is pizza. So similarly, because it is derived from the Latin language, so this is not piezoelectric. The best is piezoelectric, but that's okay. So piezoelectric materials are those materials, right, that if you apply force on them, then they will emit electrical current or voltage. And if you pass electrical current through them, then they will bend or show some deformation. So these have very specific applications in industry. New processing techniques to improve product life and fatigue properties, right? New processing techniques, that is new manufacturing techniques, which can improve the product life and which can improve the fatigue properties are which ones? The choice is isothermal forging, IF, powder metallurgy, PM, die casting, DC, and isothermal forging and powder metallurgy. So if you went through chapter 1 a little carefully, or you go back and quickly visit it, then isothermal forging and powder metallurgy are two very new techniques developed only in the last half century and so on, suppose, and they can increase the product life of a lot of products and the fatigue properties, those machines which go through cyclic stresses, up and down, up and down, up and down, like the piston cylinder in the car, it is a fatigue motion, or a motor or a generator, it is rotating all the time, so it is a fatigue motion, right? So this is the answer. Let's go to the next one. Fullerene and graphene are types of which material? If again you did the chapter and you read the definitions of the different classes of materials, metals, polymers, ceramics, and so on, then the answer would be very clear. The choices were nanomaterial, electronic material, biomaterial, and composite. So if you go back and you will see, or if you remember, fullerenes and graphenes are types of nanomaterials. They are the most common nanomaterials. There are one or two other famous nanomaterials, but fullerenes are one type of nanomaterial and graphene is another type of nanomaterial. Most abundant metal in the Earth's crust. No, not most abundant material. We could have said most abundant material or most abundant element, but metal in the Earth's crust, and we discussed about it a lot. Silicon, iron, aluminum, sodium, right? So you know silicon, right? Silicon. I have forgotten to write the one more choice. No, generally there are 4 choices, sorry. So all the 4 choices are there. So it is silicon, and we discussed it. Remember that iron has been there in the Earth's crust and it has been used for 2000 years plus, and now we are changing a lot to aluminum alloys in car bodies, in aircraft and so on, and the future is all electronic materials. So there is a lot of silicon in the world. Next question, which I have already shown, is most important material property for high speed civil transport is what? So first of all, remember, high speed civil transport is not a bus, is not a train. We are talking of aircraft. We are talking of aircraft which is very big, right? Which can carry hundreds of passengers, and still it is very high speed. Sorry, I have missed an E here. I am typing, so those errors can be there, right? Normally, very high speed aircraft is only for defense purposes, fighting jets. But in the future or in the near future, like earlier also there was a plane which is now no more being used, which came from America to Europe, which was supersonic. Now they are trying to go back to supersonic planes so that they have hundreds of passengers, but the speed is very high. So most important material property for a commercial plane which carries hundreds of passengers at a supersonic speed should be what? Temperature resistance, impact strength, hardness, all of the above, right? So all of the above could also look good, but the thing is, we are saying most important. So the thing is that when it goes at a supersonic speed, then the biggest problem that it has is that the body burns because of friction with the air, because now you are going supersonic. As soon as you touch the velocity of sound, you already have a big problem. But if you go beyond the velocity of sound to 1 Mach, 2 Machs, 3 Machs and so on, then the biggest problem is the resistance caused by the friction, right? So temperature resistance will be the most important. So I am trying to I could directly give you the answer, but it is like we are including the explanation also, though you know this explanation by now, right? So what I am expecting is that when you do this tutorial, then you have already revised for quiz 1, you have already revised for quiz 2, and now you are in the preparation stage for the midterm, right? So therefore chapter 1 we did earlier, and then we went to chapter 6, and after completing chapter 6, then we were doing chapter 3, crystal structure. So by this time that we are doing these, at least chapter 1, introduction, and chapter 6, mechanical properties of materials or metals, that should be very clear in your mind. And then of course you should also prepare for some questions from the crystal structure. Question 1b, what I am saying, 1b is also 1b in your quiz 1. This was the true false part, right? So let us see. Smart materials change their properties when exposed to a specific temperature, stress, light, humidity, etc. True. This is exactly what smart means. Smart means that if the temperature changes, they change their property automatically. They are like smart. If you change the loads, stresses, then they change their properties automatically. So it is like a material is thinking. Normally there is a material, there is a metal, and it has a certain yield strength, and that is it. So you apply load or you don't apply load, the yield strength remains the same. But if we have designed the material in such a way that when you go to a certain temperature, the material changes its properties. When you go to a certain stress, the material changes its properties. That is why you call it a smart material. Shape memory alloys and piezoelectric materials are special types of composites. Are special types of composites? No, they are not special types of composites. In the previous page, we already showed you that piezoelectric materials are a type of what? So we were talking of shape memory alloys and piezoelectric materials, and I was saying that they are definitely not composites. If you remember, these two are the most important smart materials, right? So they are not composites, they are smart materials. Therefore, this statement is false. Fiber reinforced plastics are a type of high strength polymer blend. So again, if you remember, fiber reinforced plastics, we take plastics and we put fibers, glass fibers or carbon fibers inside them. That way we are making a composite material. It is very simple. Composite means more than one type of material together. So plastics are there and we are putting fibers inside. So it is a composite material. It is not a polymer or a polymer blend. Therefore, this is false. Plastic alloys are blended polymers. This is very true. Normally, alloys is a word that we use for metals. When we mix a metal with a non-metal or one metal with another metal without doing any chemical reaction, then we say we have made a metal alloy. And usually for polymers, we use the word blends. When we mix different types of polymers for special properties, we say it is a polymer blend. But sometimes we also call it a plastic alloy. So it is the same thing. It is the same thing. So this is true. Nickel-based high-temperature superalloys are modern aerospace materials. So without thinking, right, aerospace materials, aerospace, right, in aircraft, in rockets, and those type of things. So nickel-based and high-temperature superalloys. Superalloys already mean that they have very special strength and hardness and toughness and so on. And if they are also high temperature resistant, then yes, in aerospace, they will be definitely used. So this sentence is obviously true. Let us now go to the second question of quiz 1. If you remember,